Hey everyone, welcome to my channel. So now we are going to do the fourth question for today's Leetcode weekly challenge. So it is again the medium level question, not the hard one. So yeah, let us go ahead with the question reading part for the same. So here you are given an integer n representing the number of nodes in a perfect binary tree consisting of nodes numbered from 1 to n. The root of the tree is the node 1 and each node I in the tree has two children, where the left child is 2 into I and the right child is 2 into I plus 1. Here, as it is a perfect binary tree, so it will be having, means each root will be having two childs, means it will be surely having those two childs. It is not like at most two child, it will be surely having those child. That is what they are saying, has exactly two child. And then each node in the tree also has a cost representing by a given zero-index integer array cost of size n, where cost I is the cost of node I plus 1. You are allowed to increment the cost of any node by 1 any number of times. Return the minimum number of increments you need to do to make the cost of path from the root to each leaf node equal. So basically, if we are given with a small tree like this, 1, 2, 3, right? So here, if we say its cost is 5, so its cost should be, if its cost is 2, then its cost should also be 2. So that is what they want us to do. So say if its cost is 3, so then we will be incrementing it by 1, and this is the answer which we will be returning. So this is what they want us to do. Earlier I was thinking that I can just directly check do DFS and check each path means traverse it means while doing DFS I can get that where I get to any leaf node I'll check that how many cost is there till now, and accordingly I'll store each cost and whatever would be the maximum cost. So I will try to make, not try to make, but exactly I will be then making each cost which I extract from each path equal to that maximum cost. But the thing is that here we are not given with the tree node, right? Instead of that, we are given with the cost array. And because of that cost array, now what we are required to do is we will be doing DFS only, but doing that DFS would be while using the fact that it is a perfect binary tree. And because of that only, we are having the child node as 2 into I and 2 into I plus 1. Using this fact, we can easily traverse the tree with the cost array which is being given to us. So this is how we will be required to do this particular question. Now the next thing is that how DFS would exactly work on the same. See, here when we will be traversing because of that DFS, then it will first go till the end of this node, right? And we will be getting the cost. And then because of the DFS only when it backtracks, so it will go towards the right side, right? And when the leaf node is reached, so we will be getting the cost of that particular also. So now what we are required to do, we will be getting the absolute value of the left and the right side and adding up whatever the value we were having till now, cost we were having till now for the root. So this is what we will be doing. And while doing this, then after this, then it will traverse to this, and then it will go to its basically this its right side, and then it will go to its left side. Again, the same process will happen, right? Until this, we will be getting some cost, right? So because of this, we got the cost of this left subtree and right subtree, right? And as we were equalizing this subtree, means basically these two and these two with each other, and then whatever we get, then we will be having that till now. And then we will be checking that what is the difference between these two and adding up with this. So like this manner only, we will be easily able to utilize the whole binary tree which is being given to us. And thus at the end, we will be getting the minimum required addition This is being required to make the whole binary tree as having from root to leaf path as the same. Basically the cost of that particular path. So this is what we are required to do. Now let us go ahead with the coding part for the same. So here we can clearly see the constraint are as per the binary tree only. And as we will be doing DFS, so because of that, how the time complexity and space complexity would be. That is what we will be checking. And the thing is because we are traversing through this particular binary tree which is there, right? So it will be again the time complexity of traversing is basically doing the DFS on the same would be order of n. But the thing is that it is the perfect binary tree and height, then it would be directly equal to log n, right? The other thing which is there. So because of that only, the time complexity will directly become log n. But and we are not using any extra space, so that's a space complexity will be order of 1. Now comes the part that how we are required to do this question. Now here our answer is there, which we will be returning at the end. And first we are required to do the DFS. So in this DFS we are passing this n, which is being given to us. And basically what it represents in that question only it was mentioned, right? That n basically represent here given an integer n represents the number of nodes in that tree. So that is what n represent here. So the number of nodes in that tree that we are passing here, and then this particular cost vector we will pass, which is there, and this is first we are passing the root because we are starting at DFS from the root, and this answer in which we will be storing, and here we are passing by reference so that we can directly get that answer here. Now comes the part. If root is greater than n, then we will be returning 0. That is already greater than means we have reached our base case. Because in DFS, the thing is, for DFS, we are required with a base case because DFS is based upon recursion only, right? So we require a base case or recurrence relation, which should be there. And finally, the return statement means how we are returning our answer. So these are things. So here our base case would be this one, that when we are required to stop is when our root becomes greater than n, then we are required to return 0 because at that moment we are not required to add anything. So that would be our base case here. And then comes the part that what exactly we have choices, which are the part of which will form the part of our recurrence relation itself. Now the choices are that we are required to go towards the left and towards the right because it is a tree. So we are having these two choices. Then at that moment, whatever would be the left cost, that would be because of this DFS cost. And see, here instead of root, we will be passing the left node. And how we are representing the left node, that is by 2 into 1. So that is what we are doing. And I want to say for the root. And here, it would be 2 into root plus 1. That is our right. As all things would be same. Now, what we are required to exactly add to our answer would be whatever the absolute difference would be there. Because we are required to equalize both of the paths, means basically equalize the cost of the both of the paths. So that's why we are adding up absolute difference to our answer. And then what we are doing is we are returning that maximum out of whatever the left or right cost were there and adding up whatever the cost of the root minus 1 was there, that we are returning. And this is we are returning so that we can get for a next subtree that this is the target which we have reached from our previous subtree, and this is what we are required to acquire when we reach towards the same level of the next subtree. So that's why what we are doing here is whatever would be the maximum left cost or right cost, and we are then adding up that with the cost of root minus 1. So this is what we are returning here, and while doing this we will be able to equalize our whole tree. So yeah, this was all for the same. The time complexity here is order of log n. because here the tree is a perfect tree, right? And this phase complexity is order of one only. But as we are doing the FS, if we include that recursive stack, then surely it will become log n. But one more thing is there that we are going ahead with no, but it is already a perfect tree. So there won't be a case that because when it was not a perfect tree, then there could be a case of skew trees and it could have been gone to order of n because of the skew tree, but here that is not the case, so that's why the time complexity is log n. So this was all for this particular question. If you have any doubt, you will comment it down. So this was all. Thank you.